Question. Let's start by drawing a picture. An offshore well is 6 miles off from the coast. We'll call this the well, 6 miles down. Call X coast. A gas line is to be laid from the well to a refining station that is 14 miles down the coast. So we'll call this line is 14. And this can be the refining station. This would be the distance from here to here. And we know this to be 14 minus x, because 14 is a total and x is just this. The cost to lay the line is $23,000 per mile along the shoreline and $32,000 per mile under the ocean. We wouldn't want to go all the way here and then all the way here, because that'd be highly inefficient. Instead, the more efficient way would be looking something more like this. This goes here. How can we find the length of this when we already know the length of this? So we just have to find the length of this, multiplied by how much that costs, which is $23,000 for this one. And this one would be $32,000 times the length. Well, we can use the Pythagorean theorem to find this length. That would be A2 plus B2 equals C2. And we know A2 and B2 just from these two. So we know that the length of this would be equal to radical 36 plus x2. After we do this, we can come up with an equation. This would be the total cost. The normal cost equation, we want to find the most optimal cost for the gas lines to be laid. And in order to do that, we just have to find the derivative. And we can make a new equation with 0 equals. 14 times 23,000 does not have a constant. Therefore, it does not exist. It doesn't have a derivative. If we do the rest of this, you would get something along the lines of negative 23. Okay, so this would be 23,000 negative x. When you do the derivative, the variable would disappear because when you get this, the x is a 1, and then it would minus 1 when you find the derivative, equal to 0. And x to the power of 0 is 1. So this whole thing would cancel out. 1 would multiply 23,000, and then it wouldn't change the variable. So this is part of the equation. As for the bottom, 32,000 multiplied by this, the derivative is, first you put this number down, this is equivalent to 36 plus x2 to the power of 2. This would make things a lot easier to do for the derivative. The first thing you would do is put half in front of this, and then the x to the power of 2 would turn into a 2 here. After that, half would minus 1 and would be equal to negative 1/2. In order to get rid of the negative exponent, what you can do is you can put this variable or this number underneath. And what that would do, it would change the sign of the exponents. So this would turn into the normal 1/2. So it would be 36 plus x2. You put the radical. Half and 2 would cancel out. And actually, it should be 2x here. And so what happens is the x remains on top. So you get rid of this and put an x here. And then what you can do is you can solve this equation out. So you put 23 on the other side by adding 23,000 to both sides. And you get 23,000 equal to 32,000 divided by vertical 36 plus x2. And this is basic math you can do with a calculator. And then what you can do is you can multiply this by that, and then 23,000 divided by 32,000. And what you would get is 32,000 divided by 23, because the zeros cancel out, is equal to 36 plus x to the power of 2. And when you calculate this, what you get is, this is equivalent to 1.391. And to get rid of this radical, you just have to add the power of 2 to both sides. This would become 1.936. And when you put it back in the equation, 0.936 is equal to 36. Oh, I forgot the x here. There's an x here because the x from 32,000 does not disappear. When it divides 23,000, it remains. And this is the power of 2, and 36 plus x2. You want to minus x to the power of 2 from both sides, so what you would get is 0.936 x to the power of 2 is equal to 36. Once you do this, you can find x to the power of 2 is equal to 36 divided by 0.936. And the answer to that would be 38.6. When you do the square root of this, you would get x equals 6.202. After you find x, you can go back to the original equation here to find the cost. So let's put it back in. Once you put x and you replace it with 6.202, you would get, when you calculate this out, the answer that you get is 455,491.57. This is the total most optimal cost for this whole equation.